Okay, cool cats and kittens. Today we're going to talk about quadrilaterals. We're going to compare and contrast the attributes of quadrilaterals. Um, you should remember that quad, the prefix quad means four, so we're dealing with all four-sided shapes today. And I have an acronym for you to remember when you are comparing and contrasting, which comes in handy um, to just help remember to think of all the different similarities and differences. So the acronym is PASS, P-A-S-S. And the P stands for parallel sides. The A stands for angles. The first S is side lengths. And then the last S is symmetry. Um, so let's compare and contrast these two shapes. The first step is to label the shapes. We have a parallelogram here on this side, and on this side we have a trapezoid. If you wanted to get really specific, you would call that an isosceles trapezoid, but we don't need to do that. So we're going to look at the parallel sides. A parallelogram, as you know, has all opposite parallel sides. Opposite meaning straight across. The trapezoid has one set of opposite parallel. So if we stretch these sides out onto infinity, they would never intersect. They would never get closer together or further apart. They're always going to be the same distance, kind of like train tracks going in a straight line. The rails and the train tracks would never get closer together or further apart. So the trapezoid has one set of parallel sides. These two sides, obviously, they would intersect somewhere around here probably if they extended out further. So two sets and one set of parallel sides. So I'm going to indicate that on our Venn diagram here. This intersecting part is for both attributes of both shapes. Over here is specific to the parallelogram, and this section is for what makes the trapezoid unique and different from the parallelogram. So both have parallel sides. The difference is the number. Parallelogram has two sets of opposite parallel sides. I don't like how that formatted, so I'm gonna take the line space out of there. And then I could just kind of clone. Well, let's do this. I want to clone it because usually makes it go faster. And the trapezoid has one set of opposite parallel sides. I spelled parallel. Why did I spell it with two L's at the end? There we go. Okay. Next, so that was the P in PASS. So I'm going to take my marker and check it off. Now we're going to look for the angles. We have right angles, acute, obtuse, opposite, adjacent. So let's take a look. Do we see any right angles here? No, there are no right angles. What about acute? Acute means less than 90 degrees or smaller than a right angle. Here's one. This one's bigger than 90 degrees, so that's obtuse. So we have an acute here. If we come over here, this is another acute. And then we have an obtuse here and obtuse here. So two acute that are opposite and two obtuse that are larger than 90 degrees. Let's take a look at the trapezoid. Here's an obtuse angle here that is bigger than 90 degrees and less than 180. And there's another one. Now, if we look over in these two angles, these are both acute. So these are not opposite. These are actually two adjacent obtuse and two adjacent acute. So they're similar in the fact that they both have acute and obtuse angles. So two acute and two obtuse angles. And then we also want to point out that that is a difference because we could say opposite acute and obtuse angles. Meanwhile, the trapezoid, they're not opposite. They have acute and obtuse angles, but they're actually right next to each other, which means they are adjacent acute and obtuse angles. Adjacent means next to. Boom, boom. These two are next to each other, and these two are next to each other. So that actually ends up being a difference, a similarity and a difference. So what happened here? Paragraph, line spacing. Turn that off. There we go. Now we can put our second check mark down, and now we're going to talk about side lengths, congruent, and then opposite and adjacent. So congruent means the exact same. So our parallelogram over here has, where's my eraser? Here we go. I'm going to erase all this stuff. My parallelogram has, for side lengths, it has these two sides are the exact same and congruent, and then this side and this side. So the opposite sides are congruent. Trapezoid, this side is not congruent with this side, so these two opposite sides are not. However, on this trapezoid here, we have one set of opposite congruent. So the parallelogram, two sets of opposite congruent. In the trapezoid, one set of opposite congruent. Maybe we'll just change the whole wording. So two sets of opposite congruent sides. I'm talking about the side lengths. And we can talk about the trapezoid like we pointed out. One set. Let's change that to one sets and take off my plural S, and boom, one set of opposite congruent sides. Okay, so we just finished up side lengths, and now we're on to symmetry. We have lines of symmetry and rotational symmetry. So let's take a look at the parallelogram first. Any lines of symmetry? Well, let's see. If I folded it down that line, it seems like it would have symmetry because this side has the same exact area of this side. However, if I folded this across that line, this corner does not match up with this corner. It would end up somewhere out here, and this corner would match up like maybe right over there. So that would not be a line of symmetry. Now, what if we took this and folded this shape down the line here? Once again, they're the same exact areas. However, this line would line up right here. It would not come all the way over and hit this corner, I should say. So a parallelogram, although it looks like it might have symmetry, it does not. Now let's take a look at the trapezoid. If I fold it right down the middle, that does have symmetry. This corner would end up matching up with that corner, and this corner would match up with this corner. So that would be symmetrical. Now, if I did it this way, no, obviously the top corners would not match up with these bottoms. So the trapezoid has exactly one line of symmetry. Definitely no symmetry going this way either. So one line of symmetry for the trapezoid, no lines of symmetry for the parallelogram. So I'm going to put that down as well. So as differences, no lines of symmetry. And finally, one line of symmetry. Now, you might have been wondering, wait a second, well, that parallelogram would seem like it should have symmetry. It does have a type of symmetry called rotational symmetry, where if you flip it on its head upside down, it's the same exact shape. Trapezoid does not have rotational symmetry. So when you flip that upside down 180 degrees, boom, no symmetry. You have to flip it all the way completely around 360 degrees for it to be the same shape, which means it does not have rotational symmetry. So if you really wanted to squeeze the orange and get as much juice possible, you might put rotational symmetry over here. And you could even put no rotational symmetry on the trapezoid. No rotational symmetry. And we're in the business of trying to get as much description as possible. We know that they're both quadrilaterals, so that is definitely a gimme of what they have in common, because they both have 4 sides. So quadrilaterals, I want to put 2 L's in a row there for quadrilaterals. And polygons. So those are 2 terms that they both share. They're both quadrilaterals and they're both polygons. Okay, so that's an example. I could go into another one where we could compare a rhombus and a rectangle. You can see off the bat the angles are different. Right angles, obtuse and acute angles. We might have some similarities that are a little bit different from the ones that we just did, but I'm not going to make this video an hour long and do that. So we'll leave you with that. Remember the acronym P.A.S.S, parallel, angles, side lengths, and symmetry. And if you ever need to go back and take a look at one of these videos to help you, if you get confused, feel free. That's what they're there for. Good luck today and have a wonderful day.